Hello everyone, today we'll start part 2 of chapter 15, light. The topics which we'll see are image formation by lenses, sunlight, white or colored. Now image formation by lenses. Now before starting this topic, you should first know that what are lenses. Nowadays you take so many photos, selfies, okay, there are professional shoots. So you have seen that in our mobile phones there is a lens. Okay, lens is present in our mobile phones and cameras. So what is lens? The kids who have spectacles, there is lens in their spectacles. Our human eye, the very best example, in our eye also a lens is present. So let's define what is lens. A lens is a piece of transparent refracting material which is bounded by the two surfaces. Both the surfaces of a lens are spherical. By this we mean that, okay, in the first part we discussed about mirrors only. Now in this we are going to discuss only about lenses. So lenses have spherical surface, okay, they are bounded by two spherical surfaces. Now lenses are of two types, convex lens and concave lens. Same as in case of mirror, we were having concave and convex mirror. Similarly, lenses are again the same type, convex and concave. But now in this, the action is completely opposite. Convex lens is also known as converging lens, whereas concave lens is also known as diverging lens. So we'll discuss these both lenses one by one. First is convex lens. This is the structure of convex lens. It is thicker at the center and thinner at the edges. You can see as we go on the top and the bottom of this lens, it is getting thinner, but at the center it is thick. Our human eye, the lens which is present in our eye, it is of convex type. Okay, the human eye is a convex lens. The water droplet, that is again an example of convex lens. As convex lens converges the rays of light falling on it, so it is known as converging lens. Converge means when light rays are coming at a point, when the light rays are meeting at a point, that type of lens is known as converging lens. Here what we have taken convex lens and we have placed it in the path of light rays. Here the source of light is, let's say, sun. Okay. So the rays coming from the sun, when they enters this lens, so the action of convex lens is converging. So the light rays which were earlier parallel to each other, now after refracting, the light rays are meeting at a point, and here we have taken a screen, a piece of paper. So all those light rays are meeting at a point. After some time the paper starts burning where the bright spot is formed. Now the point at which all these light rays are concentrating, a large amount of heat is there, and due to that the paper started burning. So this activity shows what? That convex lens has converging nature. Now, okay, this is very much similar to our human eye. Let's imagine this is our eye and here is any object, and from let me draw it, then it will be more clear. Suppose we are seeing any tree and this is our eye. In our eye, convex lens is present. This is structure of our eye. So the light rays emitted by this tree are falling. Let's make a bigger lens. These light rays are falling on our convex lens, that means on our eye, and after refraction, the refraction is bending of light. The light rays will bend and the light rays are meeting at a point, and this point is where? It is on the retina, and here image of this tree is formed, and that is how we are able to see that tree or any other object. The point at which the light rays meet is known as focus. Now image formation by convex lens. Here what you need three things. One, the object we are taking is candle, then a convex lens and a screen on which we will obtain the image of our candle flame. Now place a lit candle at a distance of about 50 centimeter from the convex lens. Okay, we have kept it here. The position of convex lens is between this candle and the screen. Okay, now bring the candle more closer to the lens. Initially in this case, what we are observing that the image of candle is obtained on screen. And what type of image is this? This is real image. As we can see, the image is inverted and we are obtaining it on the screen. So it is real image and real and inverted. But as we brought this candle closer to our lens, now you can see the image of candle is not obtained on the screen, but we are getting the image on the lens only. So what type of image is this? You can see we are obtaining it on the lens only and it is erect. So this is virtual image, and you can see the size of the image, it is greater than the size of the object. So by those activity, what did we observe? We saw that when the candle was far away, the image of the candle was diminished, that means smaller in size, real and inverted. But as we brought the candle closer to the lens, the image becomes enlarged, real and inverted. But when the candle is the closest to the lens, the image formed is enlarged, that means very bigger in size, virtual and erect. We will perform the same activity. Taking convex lens, and we know that the nature of convex lens is converging. So when the light which is coming out of the flame, when it falls on our convex lens, those light rays are meeting at a point, and the point at which light rays are meeting is known as focus, and we are getting image at that point. So now the image is formed on the screen. So that type of image is real, and we know that real image is always inverted. As you can see, the flame of candle is inverted. So by this activity we can conclude that convex lens is of converging nature. Now what are the uses of this convex lens? It is used in magnifying glass and in the camera. In the camera, the lens which is used is what type of lens? Convex lens, and the same example of human eye, convex lens is present. Here comes your internal question which you have to write on page 190. Give two applications of lenses and mark the answer under the topic application of lenses. Mark any 2 points in cameras, in telescopes, in compound microscope, in magnifying glass. Then second type of lens is concave lens. The structure of concave lens is this. It is thinner at the middle and thicker at the edges. It looks like this. Concave lens is also known as diverging lens because it diverges the rays of light falling on it. So it is known as diverging lens. This is the action of concave lens. When the light rays which are parallel to each other, when these light rays falls on this concave lens, then the rays are bending, but in which direction? In the outward direction. So here you can see after refraction the light rays will never meet because they are diverging, they will not meet at a point. But if you will extend all these light rays in backward direction, then we will get a point which is known as focus, and by this we can say that it appears that these light rays are coming from a point, and that point is known as focus. So the type of image obtained from concave lens is always virtual and erect because it appears to be coming from a point, the light rays. Then image formation by concave lens. We'll take a concave lens and a screen. Okay, using your brain, as I told you that the image formed by concave lens is always virtual and erect. So will we obtain the image on the screen? No, never. So the image of the candle will be obtained on the lens only, and this is, you can see the image is erect and diminished. So place a lit candle in front of concave lens. Yes, we did. So the what type of image is formed? The image formed is always virtual, erect and diminished. no matter what the position of candle is. If you are keeping it far away from the lens, then also it will be obtained and the size will be smaller. If you will bring this candle closer to the concave lens, then also the image will be diminished, virtual and erect. Okay, the next topic is sunlight, white or colored. Everybody has seen sunlight. Okay, now this is winter season, we prefer to sit under the sun. Why? Because of the heat, to get the heat of the sun. So this is the rainbow, a natural phenomena, and it is formed when? During rainy season. During rainy season, so many water droplets are present in our atmosphere, and when the sun rays fall on those water droplets, so those water droplets acts like a lens, so that the ray of sun, it is scattered into different colors, and those colors are obtained in this way, and this phenomena is known as rainbow. So it is a beautiful pattern of colors formed in the sky after or during the rain when sunlight falls on tiny raindrops. Do we mean that sunlight is colored or is a mixture of different colors? Okay, answer this. The rainbow is formed. It is the result of sun rays only, because sun rays are scattering into different colors. So by this, yes, we can say that sunlight, it is a mixture of different colors. And that is, the scattering of sunlight is known as dispersion of light. Here in this activity, what we need a prism, glass prism, a white light. Okay, when this white light falls on this prism, so the white light, as it consists of 7 different colors. So this white light breaks into, it scatters into 7 different colors, and you can see there is a bending in the ray of light. So this bending of ray is known as refraction. Okay, so after, when the light rays will come from this side of the prism, it will be in 7 different colors, and we will obtain all those 7 different colors on a screen, and this band is known as spectrum. Okay, this band of 7 colors is known as spectrum. And what are the colors we obtain? The colors are violet, indigo, blue, green, yellow, orange and red. Orange short, we call it Vibgyor. So in this spectrum, you can see red color is obtained on the top, whereas violet at the bottom. So why there is the difference? Because you can see that the red light travels with the most speed. That means it is the fastest ray. So there is least deviation, there is least bending in red light. Whereas in case of violet ray, it travels with the slowest speed, and there is the deviation. There is the maximum deviation in the case of violet light. So Vibgyor, this stands for 7 colors, namely violet, indigo, blue, green, yellow, orange and red. These 7 colors can also be seen in rainbow. Okay, in rainbow, if you have seen the soap bubbles, in that also you can see 7 different colors. Then in case of that CD, compact disc, okay, if you will bring it near the light, then also you can see different colors. So that is all dispersion of light. So is it possible to get white light by mixing the 7 colors? Okay, till now we discussed that white light consists of 7 colors and it scatters when it falls on a glass prism. So can we do the opposite like this? Here we were obtaining 7 different colors on the screen. Can we mix all these 7 colors into a one light ray, that means a white light? Yes, we can do the same. But how? Before doing that, we'll see this another activity. What you need a simple disc, and you have to color it with 7 different colors, which is of rainbow Vibgyor. Okay, at the center of the disc, make a tiny hole like this. Take a refill of a ballpoint pen and fix this disc on its tip in such a way that disc can rotate freely, like this way. This one is very simple, you can perform. So when you will rotate the disc, you will see that when you will rotate it in a very much high speed, then you will see that the colors, which are these colors, 7 different colors, after rotating they will get mixed with each other, and you will see a grey white disc. Is it actually a grey white? No, but it is a mixture of those 7 colors. So yes, we can say that we can recompose all those 7 colors into a one light ray, that is into a white light. Now initially for this what we need? We need 2 glass prisms placed opposite to each other. You can see the position of the glass prism. So in first prism, white light is falling on it. Okay, after refraction it will scatter, it will disperse into 7 different colors. Okay, now out of this prism we are getting 7 different colors. Now when all those 7 colors will fall on another prism which is placed like this manner, then all those 7 rays, they will bend, they will show refraction, and they will come out as a single white light. So by this activity what we are getting? We are recomposing our white light. So what is the conclusion? The mixing of 7 colors gives us white light, and whereas white light scatters into 7 different colors. So sunlight is a white light and it contains 7 different colors. So that was all about this chapter, light. I hope you understood the chapter well. Thank you.